What's going on everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at data as an introduction to an entire topic of maths. Data is incredibly important because it allows us to compare two things in our lives and actually talk about them without kind of guessing or using our own personal opinions in order to make an argument. So if you're talking about who's better between two basketball players, which artist is better, or even what's a better food to have for lunch, being able to understand and compare data sets is incredibly important, and it will allow you to move through life easier, making better decisions along the way. In my personal opinion, I think that learning how to understand and interpret data sets is one of the most important skills that you're going to need for the 21st century. Data is now the language of everything that we do. If you're reading a news article, if you're just scrolling Instagram, no matter what, you will see people pushing evidence or pushing an idea based on a specific set of data. If you can't interpret and understand what that data is saying, you're likely to fall for things that maybe are over-exaggerated. Having statistics to back up your argument is super important. It's basically a fact that if you don't have statistics to back up your argument, you can't argue your opinion. You need data to back up your points and consolidate your point of view. So understanding this data for yourself, being able to talk about it really well, and also be able to interpret data that's coming in is super important and will help you navigate a whole bunch of information as you go forward. So what we're looking at in these next three lessons is these things called measures of center. And this is finding, hey, in this entire data set, what's kind of the middle? What would I expect to happen if I ran this again? And the first one we're going to look at is this thing called the mean. You've probably heard it called average before, but mean is the mathematical term that we're using. I always remember it because if you said someone's average looking, that would be a mean thing to say. So average and mean are the exact same. So finding the measure of center just helps me if I pick someone from my data set at random, what could happen? What would be most likely to happen if I did this thing again? It'll just tell you something that's occurring in the middle of your data set, and it's a good way to get some information really quickly from one number. So a question could look like this. What subject are you better at? You got these marks in English and these marks in maths. So which one should you do? The English marks, you've gotten around 80 every single time. You're really consistent around that 80% mark, which is great. But then in maths, you've got a couple of lower scores. You've got a couple of really high scores. That 97, probably watched a few of my videos, helped bump up that number. But it would be really hard to just compare these two data sets just by looking at them. So we want to have a measure of center to tell us what could happen most likely if we ran this again. So what the mean is that we split the total amount of marks that we got in both of those. So the 5 English tests and the 5 maths marks, and we divide this overall total into even chunks. And we know that split and divide mean the same thing. So we're splitting the overall that we did into even groups. The biggest thing that I always tell my students is that you have to guess before you start. Because it's a measure of center, if you have a guess before we go and guess something in the middle, you're probably going to be right. It'll just give you a really good ballpark just in case you miss a number in your calculator or you do something wrong in the calculation steps. If you guess first, you're never going to be surprised. So that's my number one tip. Before you get started, always have a guess before you start. I even like to write it down. You don't have to, but that's my pro tip. So the formula for finding the mean is that we add up the total. So we add up every score together and then divide it by the number of times we did do this thing. So it's the total number divided by attempts. And once you've got that, you can do mean and average every single time. So let's have a look at what our average is for our maths results. Before we get going, I want to have a guess. So my lowest mark is 59 and my highest mark is 97. So I'm going to guess a number that's kind of in between there. Those two 83s definitely help me out. And then that 72 would probably pull me back again. So somewhere in between kind of 72 and 83 would be a really good answer. A really good guess here would be somewhere around 80. That's what I'm going to guess going into my calculations. So if my answer is crazy different to 80, maybe I did something wrong. So all you've got to do in order to work this out is use the fraction button on your calculator, add the scores, and then divide by 5 because we did 5 tests. So this is just 72 plus 59 plus 83 plus 83 plus 97 divided by 5, which gives the answer of 78.8. So that is my average score. That's super close to my guess, so I know I'm on the right track. So when you are using your calculator, you've got two options. I highly recommend using that fraction button. It just means you can't make a mistake. So if you hit those fractions, all the adding up happens on the top, and then just divide it by how many numbers you added up in total. And that's all you've got to do. Hit equals, you get the right mark. The other way you can do it is add up all the results, hit equals, and that'll give you your total, and then divide in a second step by the total number of scores. The reason that I recommend using the fractions is that it's really, really easy to make a mistake in this second go. Some people don't like having the fraction, they like to just have it all in one line, which I totally get, but you've got to make sure that you hit equals, a number comes up, the total, and then you do answer divided by the number of scores. If you do it in one line, you're definitely going to get it wrong. And we're just going to see an example of that right now. So here we're trying to find an average for my English scores. And so I'm between 71 and 84, with most of the numbers being around 80. So a guess of 81 totally makes sense. I think that's a really good guess. So in your calculator, if you did it all in one line, it would look something like this. 81 plus 84 plus 71 plus 84 plus 80 divided by 5 in one line. Unfortunately, your calculator is not as smart as you. The divide by 5 only accounts for that last number, the 80. So it's not dividing everything by 5, it's only dividing that one number. So if I threw that in my calculator, I get a number that's not even close to my guess. 336, there's no way that's the middle of this data set. That doesn't make any sense at all. So just making sure that you've got that guess first will stop you from making a mistake like this. So what we do need to do is add up all these numbers, hit equals, and then divide by 5. This is equal to 80, so that makes way more sense. So one thing we do have to look at is the pros and cons of using the mean as a good measure of center. And we're going to do this for all of the measures of center that we look at. So the big pro for the mean is that it accounts for all the data that is possible. So every single kind of input into your data set is accounted for when you do the average, because you have to add them all up and then divide by that number. But one of the big issues with this is that one score that is completely out of the blue, right? Maybe you were sick that day when we did the test, or maybe in cricket someone dropped a catch and you're terrible, and then you went on to make heaps and heaps of runs. So it could be out of the blue, a random circumstance that changes the outcome. And in this example, this doesn't represent what would normally happen. It's still accounted for in the mean. So one example, if we look at those English scores again, let's say that there was a problem with the computer marking, okay? Instead of having 71, the computer read it as 7.1. And then if I added up all these scores, but not 71 with 7.1, I'd get the average of 67.22. This is now completely out of my range, right? All my other scores were around 80, and now I've got my average, or my center mark, is way, way lower than that. And it might not have been a computer mistake. Maybe you were sick that day, maybe a pen ran out of ink halfway through and you couldn't finish the test. Even though there was something odd about that mark, it still changes your measure of center completely. In this example, I would be more willing to bet that you would get back around the 80s if we were to do more tests than saying, oh yeah, you're a 67 student. So just having an idea of, hey, it does account for everything, even if there is an explanation for a crazy result. And that could really change how you think about something. Thanks so much for watching, guys, and I'll see you later.